Yeah, so I'm just going to be talking about developing AR, in Unity. Um, my name is Joseph Hocking. Uh, so I wrote this book about Unity, Unity in Action. So started not started as a developer, but started using Unity when I was working at this place called Synapse Games. Um, and then now that was a couple jobs ago, and then now I'm working at Qualcomm, which actually it's a funny one. Like it I didn't make the connection until we were just chatting right before the meetup started, but actually one of the teams I interact with a lot in my job is they were formerly Wikitude, got acquired, so that means like that's an office in Austria. I'm not sure where, but I interact with them a lot. Uh, anyway, newartiste.com, that's my website. And then I also, at the very bottom, I threw in another link to one of my previous job. I was working at this company called Bundle AR, which, as the name implies, they also do AR stuff. So, that's relevant, I guess. Um, all right. So anyway, first I just want to, go over like for anyone who isn't, I'm guessing most of you are, but in case, for anyone who isn't like totally clear on the different relevant initials there, you got virtual reality, which is VR, augmented reality is AR. That's what I'm going to be talking about. Um, there's also this term extended reality, XR, which that's kind of an umbrella term for both VR and AR, like basically any sort of immersive technologies. I got to admit, I don't know how widely known XR is, like sort of in general. It's the term we definitely use like internally, like for our teams and whatnot. But like I don't know if you were to just tell the average person XR, they would have any idea what you're talking about. Um, and then there's this other initials, MR, I want to point out, mixed reality. That one's more vaguely defined than the other three. Some people, sometimes when it's used, it's essentially a synonym for augmented reality. Um, Sometimes, though, it means something slightly different. I know uh, within Qualcomm, for example, and I believe like Microsoft uses the term the same way, but like it essentially means doing AR but with like VR hardware. So sort of like what the Quest Pro is doing with its pass-through cameras, that kind of thing. So anyway, just wanted to, like I said, clear up those initials before I keep going. So um, AR, augmented reality, is an interactive experience that combines the real world with computer generated content. And that picture there, that's actually the app I wrote when I was working at Bundle AR. So like that, we could show, for example, like what you're seeing there is an architectural diagram of this apartment being overlaid on top of like, this sort of like real estate listing of that apartment. So anyway, this definition of AR, it's sort of like um, combining with the real world, as opposed to what you do in VR, which is a totally artificial environment. There's no combining going on. It's just everything is this computer generated content. Um, anyway, so there are obviously, given that these are still early days for this technology, there are lots of different platforms, but the main AR platforms I want to point out, you got AR Kit, which is Apple provides to do AR on like iPhones. AR Core, excuse me, sorry, AR Core, which Google provides to do augmented reality on like Android phones. Excuse me. Um, and then you have platforms like there's Vuforia, which ironically was developed by Qualcomm but then sold off. So, yeah. And then Wikitude, although that, given that they were just acquired by Qualcomm, that no longer exists as like a separate company. And then meanwhile, Unity provides this tool called AR Foundation, which is it's not an AR platform in and of itself, but rather a sort of like higher level wrapper so that as a developer, you can just program against AR Foundation. And then when you deploy, AR Foundation will just use ARKit if you're deploying to an iPhone, or it'll just use AR Core if you're deploying to an Android phone. Or in the case of these AR glasses we're developing at Qualcomm, I personally I just program against AR Foundation, but then it uses Snapdragon Spaces, just sort of like under the hood when we deploy to these AR glasses. Snapdragon Spaces is a head-worn AR SDK that's made by Qualcomm. So, I mean, in case you're curious about that, there's the link for that. But anyway, yeah, like that's pretty much to develop Snapdragon Spaces. That's why Qualcomm bought Wikitude, but then they also bought this company, I think it was called Clay, but it's in France, in Bordeaux, that does hand tracking, and so that's also integrated into Snapdragon Spaces. Now, AR Foundation, as I mentioned, it's sort of like this higher level interface on top of the underlying AR platform. Well, as a result, though, that means that there's certain functionality provided by AR Foundation which may or may not be supported by the underlying platform itself. So then there's this grid of sort of like AR Foundation gives you like device tracking. That's referring to six stuff tracking, actually. But incidentally, another bit of vocabulary. I wish I'd written this down somewhere, but just 3DOF and 6DOF. The DOF stands for degrees of freedom. So 3 degrees of freedom, 6 degrees of freedom. 3DOF just refers to just rotation, but you don't know where exactly the thing is positioned. 6DOF is where you have both the rotation and the position data. So in other words, if you think about like VR devices, if you think about like the Oculus Go was 3DOF, whereas the Oculus Quest is 6DOF. The Oculus Go, it knew which direction you were facing, but it didn't know where you were exactly. Whereas the Quest, it's tracking both where you're looking, but also like where you're moving to, in space. So anyway, so that's 6DOF tracking. That's what this list is referring to when it says device tracking. But then plane tracking is just identifying planar surfaces in space, so like a desktop or a wall, that kind of thing. Point clouds, it's kind of a marketing thing, on a marketing bullet point that they're listing that separately, because really it's sort of like a lot of the other functionality depends on point clouds. So I don't know. Anyway, anchors is an interesting one because there are multiple ways that anchors can be supported as well. That just refers to like knowing some rooted position in space. But the thing is, there's a distinction between like local and shared anchors. Like local anchors are only anchors known to you, but not to anyone else, where shared is like you can place an anchor and now everybody looking at that spot will see content anchored at the same spot. And then of course, there's the difference between like, anyway, long story short, like I said, anchors actually could mean a few different things. So again, this is sort of a vague marketing bullet point for Unity. Incidentally, this chart just comes from Unity's website. Light estimation is just when the SDK notices lights in the environment and then you can put those lights in the virtual space as well. Face tracking just refers to like if the camera sees a human face, then it can track what the facial expressions are being made, that kind of thing. Meshing refers to before I was talking about plane tracking where the system is just detecting planar surfaces. Meshing is more of a full, like it just is capable of detecting like your full three-dimensional, a three-dimensional reconstruction of the space you're in. 2D image tracking That's refers to, this is actually probably the classic um, AR functionality of just sort of like when the camera notices an image, in the camera view, then it can, the system can, tell you where that image is now located or moving, that kind of thing. So anyway, and then so what I'm going to be going over, I'm mostly going to be talking about AR Foundation. Then, as I mentioned, it's sort of like this umbrella on top of a bunch of underlying AR platforms. Uh, so what I'm going to be going over is a bit of code for how to do. This is a screenshot that just shows like running on my phone in my bedroom, doing some plane detection with AR Foundation, and then doing a raycast against the detected plane and placing a block there. So, in this case, like I placed a block on my floor because it detected my floor, that kind of thing. So I'm going to show how to do that real quick. This kind of functionality, this is pretty much the basics for any AR system. Like it needs to really be able to do this. Most AR systems, as you've already seen, like they can do more than just this, but it's sort of like if it can't do at least this, then it's hard pressed to really be called AR. This brings up like the whole Pokemon Go phenomenon, where like people would be like, "Oh, it's an AR game." It's like, it's certainly got virtual content being combined with the real world, so you could argue that's AR, but it can't do this. Like, it can't like detect surfaces and have the virtual content like rooted in your real space. So, some people would argue like, oh, it's AR, because certainly a lot of people were saying it's an AR game. I wouldn't call that AR myself. What's funny is Niantic, the company that made Pokemon Go, they're doing a lot of really interesting work in what definitely is AR, and it's just sort of like their most visible product right now is this thing that's sort of like, well, it's not. Just as an example, like Niantic, they're partnered with Qualcomm to develop like some AR glasses and that kind of thing. So anyway, and then in the corner there, by the way, that's just a screenshot of Unity, because that's what the Unity would look like, as I'm working on this. But anyway, all right. So I'm going to switch now to the code, just so that I can show you the code that's going on here. Now, I mean, I was actually thinking like maybe I could like set up a camera or something so that you guys can see this live, but it just seemed pointless. So I hopefully you get the point, like you understand what the actual like AR live would look like on the phone. But here's the code for how to do it. So you can see the first three using statements here. These are just the typical, like, Unity's code template just comes with those three. The two using statements I've added here, both are referring to AR Foundation or needed by AR Foundation. One of them is actually called AR Foundation. The other is these AR subsystems. Notice, by the way, both of them are located inside this like XR namespace. Again, it's like I was saying, it's sort of XR. It's used a lot by developers, people developing this stuff. I don't know how widely known it is, but certainly with when you're talking to people developing immersive technologies, like, yeah, we all just talk about XR because again, it's sort of like, even though philosophically VR and AR are very different, in terms of the technologies involved, they're very similar. They're definitely related. All right. So anyway, this code. So the the core of this functionality actually is, where is that one? This one. AR Foundation provides a class called AR Plane Manager. Or I mean, it provides not just a class, it provides a component. So you can see I add component. By the way, in this code, I'm doing the add component in code. Obviously, you don't have to do it that way. You could, just um, uh, you know, with Unity, you do the add component and do it that way. You can do it visually. The the object you would be adding this AR component to is the AR session origin. You definitely need to have an AR session origin. In Unity, if you sort of do that whole sort of like right click to create an object, there's an XR section of objects. I don't remember off the top of my head if you need, I'm guessing you do need some specific library in order to get that. It may be as just like you gotta install AR Foundation. Actually, that is a package after all to get that. But at any rate, then it's going to have the two objects you can add that are very crucial for working with AR Foundation are AR Session. There's an object called AR Session, and then there's another object called AR Session Origin. I got to admit, to me, the fact that these are two different objects seems kind of redundant because they're very similar. But at any rate, you need both AR Session and AR Session Origin. And then when you add these different managers of AR functionality, you add them to the AR Session Origin object. You add them as components on the AR Session Origin. So here we've got the AR Plane Manager. As you can imagine, AR Foundation also provides you like AR Image Manager, AR, Face Manager, that kind of thing. But they're all, again, all of these different tracking functionalities just have their own manager and they work in a very similar way. In this case, then, for this demo, I just told it to only detect horizontal planes, so like the floor, that kind of thing. You could also detect vertical planes. That would be more like the wall. You can set it to only detect vertical planes, or you could do both. You could detect both horizontal and vertical planes. If your application doesn't need vertical planes, it's better to only be detecting horizontal planes, both because that uses slightly less resources on the compute side, but really the main reason is just you're going to get more accurate detection that way. It's because if it's trying to also detect vertical surfaces at the same time, it might get confused about like, wait, which direction is the surface facing, that kind of thing. Whereas if you tell it explicitly, you're only detecting horizontal surfaces, then it's just going to ignore any points that look like a vertical surface or something like that. The plane prefab, this just, so if you go back to, like, or if you think, I'm not going to switch to it, but if you think back to the screenshot where I was showing this thing, this yellowish plane, that's just, that's what Unity provides by default. Like, again, in the XR menu, you can also do like a default AR plane or something, something like that. That's pretty ugly. For your applications, you'd probably want to change from the default, but it's good to start with that default plane. Like, I know, speaking for myself, usually I just switch it to this kind of like dotted line looking, or not line, I'm sorry, dotted like plane looking thing. So, it's not like the floor turns yellow. It's more like you can just see dots appearing on it. It's usually a good idea to visualize it somehow though, because otherwise people won't get that, like, the floor's been detected. That's one of those sort of like UX niceties that are kind of unique to AR, where like you need to, because right now the tracking software is too primitive for it to be just detecting everything arbitrarily. You do need to communicate to your users, like sort of like which surfaces have been detected, that kind of thing. Anyway, And then you'll notice I also have this AR Raycast Manager that's being used. Now, it is, one could, as I did initially, one could wonder, why do we even need this special AR Raycast thing? Like, can't we just do a normal Raycast? Now that I have this, geometry in the scene. And technically, yes, I could. I could just do a normal Raycast against the plane geometry. The problem there is the only information you're getting then, it's going to be the information you get doing a normal raycast. So like it'll tell you where the hit was, and it'll tell you how which collider was hit. But on the other hand, an AR raycast can deliver more information, like semantic kind of information. ARKit, neither ARKit nor AR Core supports this kind of thing yet, but they're definitely working towards more like semantic segmentation of scenes. That's just a technical term that refers to like, the SDK can tell this is a chair versus this is a bed versus this is a desk. And so then the raycast could potentially be returning that information. You just hit a chair, or you just hit, the floor, that kind of thing. But yeah, then you can just see my code. I'm not going to go over exactly what this code is doing, but or how this code is written rather. I am going to go over what it's doing. But this code, it just sort of like it projects array. When I press down the mouse, or in good old Unity, it's even though it's get mouse button down, it's actually like tapping on the screen. But anyway, it's it just projects array, into the scene, and then if it hits like the detected plane, then you can see a plane within polygon is what it's trying to detect. But anyway, if it hits something, then it'll just put my little my little cube onto that spot where the hit was. So like I said, this is the this right here, this code, this is the basics of using AR Foundation. Incidentally, this exact script, not only is it part of the what I sent to as to go along with my slides, so like I guess people could download it later or something. This is also in my book, actually, one of the examples in my book. But anyway, if you wanted to look it up though, you would find something very similar to this just by like Googling, I don't know, AR Foundation, tracking a plane or something like that. But anyway, that's whoops. That's how to use, like I said, a very basic demo with AR Foundation. To get additional functionality, then there are just in the same way that you've got this AR Plane Manager component that you can add to the AR session object, you can add, there are components, again, I don't remember their exact name off the top of my head, but there are components that are going to be called something like AR, Tracked Image Manager, AR, Face Track Manager, stuff like that. I think I mentioned how like Snapdragon Spaces, Qualcomm's SDK for doing head-mounted AR, that's also an AR Foundation implementation, at least within Unity. We also support Unreal, but yeah, that's a separate thing, obviously. But however, since AR Foundation doesn't have hand tracking, then the Spaces SDK, they had to create like a custom component for doing hand tracking. With that though, since everything else was using AR Foundation, that custom component was purposely designed to be very similar to how AR Foundation does things. But on more to the point, I'm surprised actually AR Foundation doesn't already support hand tracking. I would not be shocked if Unity adds that in like next version or something, because it seems like most of these AR platforms are moving in the direction of having hand tracking functionality as well. So anyway, so yeah, so that was a little, like I said, a little quick overview of how one could, be working with AR in augmented reality in Unity.
Thanks, Joe. Anybody has a question to Joe regarding AR and AR Foundation?
Oh, yeah. Here, I'll just.
So somebody asked for the book title again.
The book is called Unity in Action.
Can you copy paste it in the chat?
Sure.
Any other questions?
I have one, but I wait until Joe posted his book. Thank you, Joe. Speaking of the plane with polygon, the trackable type, do you have the Unity open or just the code editor open?
I just have the code editor open right now.
Okay. So for me, it's like what the thing is like, because you can either detect, I think, whole planes, plane with polygon, points, and point with normals or something like that. And I think plane with polygon is any detected small plane versus there's a second type plane which needs to be like broad and wide and a real more floor versus plane with polygon, and then you can also decide if it should be a wall or the floor or the ceiling. Correct. So you have kind of also subtypes for
yeah, I mean, certainly when you talk about because there are a couple of different plane options, plane sounding options. Like there's plane within polygon, but then there's just plane. That really gets to the difference between some sort of like infinite plane versus like a bounded plane. Plane within polygon refers to this sort of like bounded, this is what's been detected. We're only, this is what the AR system has detected. Whereas like plane in general would be like, okay, imagine an infinite plane, but that's coplanar with what's been detected. Sometimes, given that the boundaries are not going to be exact, sometimes, for your application, it makes more sense to just like, be detecting this sort of like infinite plane. Obviously, either way, it's not going to be like super accurate to the real world in terms of the boundaries. That's where like, full meshing comes in and 3D reconstruction. That's where like it detects the furniture in your room, that kind of thing.
So I would say like this is important if you make a raycast to think about if you just want the detected plane, or if you, as you said, like imagine you're outside and have a whatever application, then it makes sense to take advantage of the full plane because you maybe have more space than
right.
ARKit has detected.
Yeah, when you refer to outdoors, that's a great example of where, like, for example, maybe the only like it's the AR system has only detected this one patch of grass, but actually, like, like.
You have a huge playground.
the ground is effectively infinite as far as your application is concerned. So
exactly.
Annie is also raising her hand. Do you have a question?
Yeah, I guess my question would be, besides reading the book, like what would you recommend us to get started, especially early on? Like I am been around VR right now. AR is the one thing that's the most interesting to me. I work at Microsoft during the summers in MR, the mixed reality org, but I didn't get to do any cool AR stuff. I mean, the HoloLens were around, it was just not my area. So like, what would you recommend me to do? Like straight away, I close this Zoom and then I go into dev mode?
Sure. Well, obviously that starts by trying to define like exactly what it is you're wanting to create. Like first off, when you say getting started, I'm assuming you're talking about getting started with AR, because I mean, if you're talking about like So already that narrows the field a lot in terms of like, okay, so what are we talking about here? But there's still this, currently there's still this big distinction between like handheld AR and headset AR, which is, AR on your phone versus AR being done in a headset, like say the HoloLens you mentioned. So right off the bat, that makes a big distinction. Now, obviously, there are practical reasons why a handset AR is going to be an easier place to start as a student, because you got your phone. Whereas like the headset, it's like, well, gee, I got to get one somehow, like, and they're really expensive, and yeah. So if you're just like wanting to start dabbling in AR in general, then definitely I would say start with handheld AR. And like I said, one of the nice things with AR Foundation, because it's sort of like it works across different what you've developed, what you as a developer write, just works across different devices. Excuse me. You wouldn't be restricted to just one kind of AR if you're working that way. Now, I don't want to play it up too much like, oh yeah, AR Foundation is the way to go for sure, because obviously whenever you're talking about a sort of like lowest common denominator kind of system, there is that annoyance of like, okay, you're limited to what they're providing. I've already made reference to how, like, for example, with Snapdragon Spaces, in order to do hand tracking, we needed to go beyond what AR Foundation provides. So I mean, like there are downsides, but still, my recommendation as a student, and if you're a Unity developer, would be like, yeah, start using AR Foundation. So yeah.
Great, thanks. And thanks for the talk. It was pretty cool. I really hadn't seen a single line of code for AR stuff. I was keeping my distance for a while. But I'm super excited like to get like a starting point on how to go into it. So thanks.
Very cool. Yeah, it's funny as AR, it's one of those things where obviously the deeper you get into sort of like the underlying technologies of it, then obviously the computer vision algorithms are really complicated, and the mesh generation algorithms are really complicated. The 6DoF detection algorithms are really complicated. But the thing is, most of these AR platforms, ARKit, AR Core, Snapdragon Spaces, they're like, the point of those platforms is to handle all that underlying tech for you, so that you as a developer can just program an AR Foundation and be like, tell me what the detected planes are, and it just returns them for you, and it's not your job to like parse the pixels of the camera and be like, where are the planes, and that kind of thing. So,
Marian is asking, what do you think of Styly as a starting point for a newbie to AR?
Styly, I've never even heard of it, which I suppose is my answer. It's like, I'm reasonably well informed about this space, the aerospace, and I've never heard of Styly, so that's not a ringing endorsement right there. That's yeah. So
looks like an app for the iPhone.
Well, so I mean, in terms of any sort of like app, and then this gets right back to where I was saying earlier in answering the sort of how to get started question. There is, you do have to define like, okay, so what am I trying to accomplish here? What am I trying to get to? I mentioned how my previous job, I was working for this company, Bundle AR. The whole point of that application was so that it wasn't just like, even though the screenshot I showed was this architectural visualization, it's not like I was creating bespoke architectural visualizations. What I was creating was sort of like this no code AR tool, so that then like people could just upload onto our website, like, here are my models and here are the images I want to track now. And then we would just download that to the application, and now, the application would be like, well, here are your images, so, or I just see your image, and so here's your model, just put on top of your image. So a platform like what Bundle AR are providing, or and maybe this is what this Styly thing is doing or something like that. That's a great way to start getting involved in AR as a creator, because there's no code required. Obviously, in terms of as a developer, that's very limiting though, because now, you're not developing an AR application, you're just kind of like making a thing show up on a detected image. Yeah, exactly. Like as a programmer, you definitely want to sort of like know a little bit more under the hood of what's going on. Although, as I already mentioned, there's kind of like this, layer of like, you want to know a little more under the hood, but then again, you don't necessarily want to get into all the vision algorithms. You just kind of want to be like, some smart people have developed these for me, and I'm just going to use their work. So, yeah.
I think it would also take too much time to do something like SLAM on a mobile device, and knowing how to address the camera and getting the video feed and making computer vision on that. So yeah, I mean, as we all know, the devices developed over the last, I would say, 7 years very rapidly in regards to AR, and they've all now more or less specialized chips inside. So I would say, Joe, it would not make sense to go deeper than necessary.
I would have a question.
you
Sorry,
agree?
please go ahead.
Well, oh no, sorry. I was just gonna point out, like, at this point, like, even though it's AR is still in early days as an industry, the industry has matured enough that it's sort of like, at least on those underlying vision algorithms, it would be hard to compete there anyway. Like, like you're not going to beat what Apple's already providing for free, so just use that. You're not going to beat what Qualcomm's already giving for free, so just use that one. So.
For virtual reality, would you also use AR Foundation as a starting point, or is there a different SDK from Unity?
So in general, the answer is no. When talking about Snapdragon Spaces specifically, the answer is it's complicated. But in general, the AR Foundation, as the name implies, it's developed specifically for AR, and it supports, like AR Kit and AR Core. Like basically, AR Foundation, although obviously at this point it's gotten away from its starting point, but originally the point of AR Foundation was that, so Apple had AR Kit, Google had AR Core, but it was annoying for developers to have to program separately for each. So Unity just created like this common layer, AR Foundation. Over time, as you can imagine, it's like AR Foundation has kind of like grown, like it's gobbled up other things, and so it's not just about handheld AR anymore, for starters. But that said, from the start, like, its intention was to be this AR platform, not a VR platform. I say with Snapdragon Spaces, things have gotten a little confused there, mostly because now I alluded to how you've got these now virtual reality devices that can do like mixed reality, or through video pass-through, and so now we're supporting AR on VR devices that are using video pass-through. But anyway, as far as the virtual reality itself, since while the sick stuff that is supported by AR Foundation applies to virtual reality as well, obviously most of those other features of AR Foundation, image tracking, planar tracking, stuff like that, none of that matters for VR. Like that is, VR doesn't need to detect your real environment. Like the whole point of VR is it's replacing the real environment with an artificial construct. So there's just no need for any of that. So.
And then it probably provides you with special interaction.
Yeah, well, that and the fact that, I mean, so since VR has much fewer like devices that are needing to be supported, like, I mean, with AR, you've obviously you've got like every single mobile phone is in theory an AR device. I mean, obviously in practice, you know, things don't work out quite that way, but in theory, you know, every single mobile phone. With VR devices, I mean, you got like, you know, you got your Oculus Quest, you got your you know, Valve Index or something, and so like Valve provides their own VR SDK, Oculus provides their own VR SDK, and like, you know, like that's, as a VR developer, that's kind of all you need to care about is you know, like the SDK provided by Oculus. So, you know.
In Unity, I think you usually use just the XR toolkit, which, so you don't really need to care if it is the Oculus SDK or the
XR toolkit. It's great that you brought that up, actually, because I haven't messed with that much myself, mostly because it's very new. Like the VR space, it's only just now getting to the point in the VR space where like it makes sense to have a sort of like, you know, combined overarching tools similar to AR Foundation, and you know, that's what XR Toolkit is towards. But so it's a much newer SDK. It, in terms of my book, for example, like I mentioned in the book like the Microsoft SDK, but like at this point that doesn't exist anymore, like because that's already been deprecated. And then meanwhile, XR Interaction Toolkit, I don't even remember if I mentioned that or not because it's so new. I might have like snuck it in at the last second, but I don't know. Anyway, so.
Annie, raising your hand. Do you have a question?
Yes. I would like to know, like, how did you get into AR? Like, it seems like you have a lot of experience, obviously. So how did you get into it, and what does it mean to you to be developing technology?
Sure, that's a long story, and not. I'll be perfectly frank, not necessarily a totally helpful story, because the first time I was developing VR was actually back in '99. So obviously back then, none of this like VR explosion of consumer VR, it didn't exist yet. Like that was more like, you know, in university we were doing like, you know, we had, you know, military contracts and you know, we're working there. The first time I started doing any AR stuff would have been not too long after that, because there's this open source tool called AR Toolkit. You don't need to, you know in depth how to use AR Toolkit because it's way outmoded at this point. But as a historical point, it's kind of interesting because so I mentioned earlier how like image tracking is kind of like the canonical AR functionality. Well, it's because of AR Toolkit. AR Toolkit was sort of like the first open source SDK for doing image tracking. And then, you know, Apple and Google and everybody else was like, whoa, we gotta, you know, have that working on our phones or whatever. And so you got ported over. Like, I remember, so before, obviously this is way back before Flash, when Flash was still a thing. I was, back in the day, I was developing a lot in Flash. And so there was an AR Toolkit port for Flash so that you could actually be detecting images on your webcam. And yeah, anyway, early days, that was real early days. Yeah. So like I said, that answer is not exactly helpful to you right now, but that's how I started working on this stuff. As I mentioned, the first time I started using Unity is when I was working at this company, Synapse Games. That was just kind of a coincidence, AR, XR wise, because I wasn't doing XR anything at Synapse Games. That was a mobile games company. But but that's where I started using Unity, because I'd never used Unity before. And then long story short, Unity started incorporating all these like XR features, like Air Foundation stuff, and so it's sort of like, oh, I'm already a really talented Unity developer. Let me start doing that as well. And anyway, so yeah.
Cool. Thanks. Sounds good. Any other question?
I would have one, but Joe already answered it with like, when do we get semantic information from AR devices? Because I left the field of AR like 2 years ago, and I was curious, like, because we were talking about this would be like from a programmer's point of perspective, nice to know where is the user looking at.
Yeah.
So since you are working at Qualcomm, I'm sure you have something in your sleeves.
Yeah, I mean, so on the one hand, in terms of the specific question, when? Yeah, I have no idea. I have no idea. But you are right. Like pretty much everybody working on AR, that's something they're working on, is trying to get semantic understanding of your scene around you. That's also why, incidentally, AI is among the places where AI gets very useful for doing augmented reality is in that kind of stuff. Basically, when I started working at Qualcomm, I didn't at the time understand, because like there were a lot of people talking about like how getting AI in Snapdragon spaces is really important, and I didn't quite understand it at the time. Like it's sort of like, well, wait, this is all like computer vision stuff. Like I mean, detecting the plane, that's computer vision. Six off tracking, that's computer vision. Where does the AI come into it? But yeah, semantic understanding is very much an AI problem of just sort of like, the AI recognizing like, oh, this is the floor, this is the wall, this is the desk, and stuff like that. So yeah.
There's also really interesting a lot of single image depth estimation with AI.
Right.
With AI, and I saw an example recently for Stable Diffusion, where they made a VR space with depth just from depth estimation. So
and then one thing that's super interesting about that, but obviously this gets way outside my wheelhouse, because this is more like what the Wikitude team does, and then that can. But like, it's sort of like there's also, so basically anytime you're relying on computer vision to do your tracking, there's a bit of a sort of like a spin up time, like where it needs to have enough images to process. So so even if the AI depth estimation, even if it isn't super accurate, it's pretty much instantaneous though. So what you could potentially do is like have instantaneous tracking that way, and then have the tracking hand off to sort of like the more accurate thing once that's cooking. But like I said, how that would work is, that's out of my hands, and that's other people work on that kind of thing. So yeah.
All right. maybe a last question, if somebody wants to ask another. Sorry, another one. Okay. Thank you very much, Joe, for the great talk and for joining us again.